Is Earth being watched by something not of this world?
Right now, something extraordinary is unfolding in the skies above. An interstellar traveler, officially named 3I/Atlas, has entered our solar system, and it's putting on a show that nobody predicted.
Do we have the technology and the ability to intercept and deal?
Instead of fading quietly into the background, this icy stranger has been doubling in brightness every few weeks, swelling into a glowing green giant that defies every forecast astronomers built for it. What makes it so puzzling isn't just the spectacle, it's the pace. Models expected a slow rise, maybe a modest flicker as sunlight began to wake its frozen heart. Instead, 3I/Atlas has leapt 6 times brighter than expected, leaving experts scrambling to explain what exactly is happening inside that dusty haze. Is its nucleus crumbling apart? Are alien ices, compounds we've rarely or never seen before, vaporizing under the heat of our sun? Or is this the kind of phenomenon that forces us to rethink how we even define a comet? With Mars looming ahead and Earth's viewing window about to close, time is running out to catch this cosmic visitor in action. The mystery is building, and the answers may rewrite what we know about interstellar wanderers. To appreciate just how unusual 3I/Atlas really is, we need to look at where it is and how fast it's moving. Right now, this interstellar comet sits about 2 astronomical units from the Sun. That's twice the distance between Earth and our star, roughly 300 million kilometers out in deep space. At that range, sunlight is weaker, yet somehow Atlas is producing a display bright enough to grab the attention of telescopes across the globe. Its speed is even more jaw-dropping. At the moment, Atlas is tearing through space at nearly 60 kilometers per second. Put differently, that's fast enough to cross the distance from Earth to the Moon in just over an hour. And this isn't its top gear. By the time it slingshots around the Sun at the end of October, its velocity will climb towards 68 kilometers per second. For comparison, the fastest planets in our solar system, like Mercury, crawl along at less than half that speed. Objects traveling at this pace don't stick around long. Every day it spends near us is precious, because it won't circle back. Atlas is on a one-way ticket through the solar system, and our instruments have only a fleeting chance to capture the data before it races back into the dark. For all the talk about Atlas growing brighter, don't expect to step outside and spot it with your own eyes. Astronomers measure brightness on a scale called magnitude, and 3I/Atlas currently sits around magnitude 12. To put that in perspective, the faintest stars you can see without any help under a perfectly dark sky hover around magnitude 6. That means Atlas is about 250 times dimmer than the naked eye can detect. Even for experienced sky watchers, this comet isn't easy prey. Observers need at least a mid-sized backyard telescope, ideally under very dark skies, to pick up even a faint smudge of light. And while its glow keeps rising faster than models predicted, it's still just beyond reach for casual stargazing. But here's what makes things fascinating: the speed of this increase. Most comets brighten gradually. Following a curve astronomers can plot and forecast with confidence. Atlas, on the other hand, has been sprinting off that chart, brightening at a pace that leaves experts rechecking their numbers. This isn't just a statistical quirk, it's a clue. Something inside this object is driving an intensity that defies ordinary behavior, and telescopes everywhere are working overtime to figure out why. If the brightness curve is the first shock, the size of Atlas's coma is the second. The coma is the cloud of gas and dust that envelops a comet's nucleus once sunlight begins vaporizing its frozen surface. In Atlas's case, this cloud has grown explosively, now stretching hundreds of thousands of kilometers across, big enough to rival the diameter of Jupiter. That kind of expansion changes everything. Even if the solid nucleus remains hidden deep inside, the sheer volume of reflective dust and gas acts like a giant mirror. Sunlight bounces off countless particles, scattering in all directions, and the result is a much brighter object than models ever expected. It's not necessarily that the core is more active than others, though it might be, but that the expanding cloud magnifies every bit of activity happening inside. Every major survey telescope has been logging Atlas's numbers in real time. The discovery team behind Atlas, who first spotted the object in July, feed constant updates to the Minor Planet Center, adjusting trajectory models and alerting the community to each brightness jump. For astronomers, the coma isn't just a pretty halo. It's a window into the comet's chemistry, structure, and the strange physics driving this unprecedented outburst. September was the month Atlas truly broke the rules. Its light curve, the graph astronomers use to track how an object brightens or fades over time, suddenly veered away from predictions. Instead of a smooth climb, Atlas spiked, a surge so sharp it forced scientists to rethink their models overnight. This wasn't a gentle uptick, it was a jolt that sparked debates across observatories, forums, and amateur astronomy circles worldwide. But just as the drama ramped up, the viewing window began to close. Each evening, Atlas sank lower into twilight, drawing closer to the sun's glare. Astronomers measure this angle as solar elongation, and once it dips below about 30 degrees, even the biggest ground-based telescopes struggle to pull a faint comet out of the bright sky. By October 21st, Atlas will be too close to the sun from Earth's perspective, effectively invisible to us. For professionals, pointing expensive optics that near the sun risks permanent damage. For amateurs, the challenge is simply beating the clock. Observers race against sunset, hoping for a few final images before the comet slips away. Some networks even coordinate globally, handing observation duties across time zones like a relay baton. But soon, Earth will lose its view entirely, just as Atlas enters its most active phase. When Earth loses sight of Atlas, the responsibility shifts to an unlikely outpost, Mars. In early October, the comet will sweep within about 28 million kilometers of the red planet, close enough for the fleet of orbiters circling Mars to try their luck at capturing data. For a brief window, Mars becomes the only front-row seat to this interstellar visitor. Each spacecraft offers a different set of eyes. The Mars Express orbiter can capture detailed stereo images and pick apart the comet's light for chemical fingerprints. ExoMars Trace gas orbiter is built to sniff out faint gases, carbon dioxide, water, even exotic molecules that could reveal what's hiding in the nucleus. NASA's MAVEN mission, designed to study Mars's atmosphere, can retool its ultraviolet spectrograph to analyze Atlas's glowing cloud, while its plasma instruments monitor how solar wind collides with the comet. And then there's the Mars Reconnaissance Orbiter, whose high-rise camera might even resolve the nucleus itself if conditions allow. Tracking something moving at tens of kilometers per second isn't easy for any spacecraft, but the geometry favors Mars, and instrument teams have already been running simulations, eager to catch what Earth can no longer see. Perhaps the most striking thing about Atlas isn't its size or speed, but its glow. Unlike most comets, which shine with a bluish haze or a muted white, Atlas radiates a vivid green light. Astronomers quickly pin this on a familiar culprit: diatomic carbon, C2. When sunlight strikes carbon-rich molecules streaming off the nucleus, it excites them into a higher energy state. As they relax, they emit photons at very specific wavelengths, known as the swan bands, right in the green portion of the spectrum. This isn't the first comet to show such behavior, but Atlas's intensity stands out. Even from a distance of 2 astronomical units, its emerald glow is unusually strong. Some researchers suggest additional contributors may be at play, such as ionized carbon monoxide CO+, or the cyanogen radical CN, both of which can fluoresce under ultraviolet light. The debates have already begun in professional circles, with teams scrutinizing calibration methods and background subtraction to confirm what's really lighting it up. Still, the consensus is clear. C2 dominates the show, and the faster Atlas barrels toward the sun, the more of these molecules are blasted free, making its green aura not just a visual spectacle, but a real-time indicator of the comet's volatile chemistry. As if the green glow weren't strange enough, observers have reported hints of a rare feature: a sunward-pointing anti-tail. Normally, a comet's dust tail streams away from the sun, pushed by radiation pressure. But under the right geometry, particles can appear to stretch in the opposite direction, creating an illusion of a tail pointing toward the sun. With Atlas racing at extreme speeds, the physics gets complicated. Larger dust grains, or those carrying electrical charges, don't always behave as neatly as smaller particles. Instead of being swept back, they can drift ahead of the comet's path, especially when the viewing angle from Earth aligns with the comet's dust sheet. To us, this alignment can project a narrow spike sunward, a feature astronomers call an anti-tail. Plasma physicists add another twist: electromagnetic forces. The solar wind and the comet's own outflow interact in ways that can focus dust into unexpected streams. These structures aren't permanent. They depend on grain size, charge, and solar conditions that change by the hour. While no peer-reviewed images of Atlas's anti-tail have yet been published, amateur and professional reports suggest it's there, adding one more layer of intrigue to an already unpredictable interstellar visitor. Every comet that wanders through our skies brings its own quirks, but interstellar visitors are a category all their own. So far, only 2 others have been recorded before Atlas: 1I/Oumuamua and 2I/Borisov, and together they set the benchmarks for what astronomers thought they might expect from foreign guests. Atlas, however, has broken nearly every pattern. When Oumuamua appeared in 2017, it shocked the world not with brilliance, but with silence. It showed no coma, no glowing tail, nothing comet-like at all. Instead, it tumbled through the solar system like a dry shard, long and cigar-shaped, leaving only faint traces for telescopes to study. 2 years later, Borisov told a different story. Unlike Oumuamua, it behaved much like a classic comet, producing a bright bluish coma, a dust tail, and a chemical signature dominated by water vapor and cyanide. It was unusual for its interstellar origin, but still recognizable. Atlas, by contrast, sits awkwardly between those extremes, and then goes further. Its coma is not just large, but enormous, swelling to sizes more typical of giant solar system comets. Its emerald green glow is unusually strong, powered by diatomic carbon in quantities that stand out compared to both Borisov and typical long-period comets. On top of that, its brightness has surged nearly six-fold above predictions, something neither Oumuamua nor Borisov displayed. And then there's the possibility of an anti-tail, a phenomenon so rare among local comets that seeing it in an interstellar object borders on the unprecedented. All of this makes classification tricky. Astronomers can't simply file Atlas under the same categories as the first two visitors. Instead, its unpredictable mix of features is forcing a re-evaluation of how interstellar comets behave, and how diverse the planetary systems that spawned them might be. No matter how spectacular Atlas appears now, its light show won't last forever. After it swings past the sun, most models predict a rapid fade. The sprawling coma will shrink, the dust will disperse, and its brightness will plunge beyond the reach of all but the largest telescopes. For casual stargazers, it will vanish completely. Even seasoned observers will need powerful optics and advanced imaging techniques to catch more than a faint smudge against the dark. But the story doesn't end there. A growing number of citizen science networks are stepping in, pooling telescope data from backyards around the globe. Using online platforms and shared pipelines, amateurs can post real-time updates on Atlas's position, light curve, and morphology. For the first time, an interstellar object's evolution is being chronicled not just by professional observatories, but by everyday observers working together across continents. For astronomers, every data point matters. Atlas's unpredictable chemistry, its surging brightness, and its odd dust behavior are all clues to how small bodies form in other star systems. For the rest of us, it's a reminder of how vast and surprising the cosmos really is. Atlas may fade from view, but the questions it raises will linger long after it's gone. So keep watching the skies with us. Hit that subscribe button, ring the bell, and share your thoughts below. What do you think is fueling 3I/Atlas's brilliant outburst? The next great mystery of the universe might be unfolding right now, and together we'll be here to explore it.